Hello everybody. Today we will work some exercises related to the topic that we learned yesterday, the nth term. Please follow me opening your math book on page 219. Let us start first solving together exercise 3. Its requirement is the table below shows a sequence of octagons made from line segments. You know that each octagon is a geometric shape which consists into 8 sides and 8 angles. Pay attention how the pattern is formed. For the first shape we have 8 line segments. For the second example or shape which are joining each other, we have 7 more, 15. For the third, we have again 7 more, 22. Since now we see their common difference, which is 7. Requirement A asks you, draw the next 2 shapes that continue this sequence. Up to now we had 1, 2, 3 for the fourth, and for the fifth sequence, we simply have to add only one octagon respectively. So four octagons for the fourth sequence, 5 octagons for the fifth sequence. What about their line segments? Their line segments, of course, will have a common difference, 7, as we said above. So it was 22. Now for the fourth, it will be 29, 7 more. For the fifth, it will have again 7 more, so 29 plus 7, 36 line segments. The requirements A and B have both the same answer, or this figure here, number of line segments, which and I've tried to give a table showing both of them, the shape and the line of segments respectively. Now for C, how many line segments are needed to make the 8th shape in this sequence? For the 8th shape in this sequence, we will try to guess carefully. Up to now, we reach up to the 5th. What about the 6th sequence? The 6th sequence will have 7 more, which is 43 line segments. For the 7th, 43 plus 7, which is 50. Then for the 8th, 50 plus 7, so 57 line segments. The answer would be there are needed 57 line segments to make the 8th shape in this sequence. The requirement D, write down a formula to show the number of line segments L needed to make the nth shape in the sequence. In order to find out a formula, we start thinking of the first position, which corresponds to 8 line segments. And logically, we will try to relate this 8 into the number 7, or 8 less than 1. That's why if we use the formula 7n plus 1, we see that this formula works. So 7 times 1 plus 1 for the first position, 7 times 2 plus 1 for the second position, which corresponds to 15, 7 times 3 plus 1, 24 plus 22 for the third position, and so on. Okay, that's why we use this formula in order to find the number of line segments needed to make the nth shape in the sequence. Now, there is another requirement. The requirement E, use your formula to find the position in the sequence of the shape of 351 line segments. Now, since we denoted by L, the position, now we will substitute by 351. 351 equalized to 7n plus 1. But this is a simple equation. We solve it using its main rule, passing 1 from the right to the left, changing its sign in order to have a positive n. 350 equalized to 7n. That's why we see then n equals to 50. So it will have 50. The shape that will have 351 line segments will consist into 50 octagons joining each other. So this is the meaning. Now open your math books on page 219, I guess, or 220, I'm not sure. Follow me solving exercise 4. Look at the tiling pattern shown in the table below. The first pattern you see consists into 1, 2, 3, 4 tiles. The second into 7 tiles. The third into 10 tiles. You see that the common difference among them is 3. 4 plus 3, 7 plus 3. Okay? The first requirement, copy and continue the table for the next 3 rows. Using this logic, first we will complete the number of tiles plus 3 each time. So 10 plus 3, 13, then 16, then 19. But how will we plot this tile pattern in the left side of this table? We will try to understand the way how the tiles are placed. In the first example, it was true that it has 4 tiles, but pay attention, we had 3 horizontally, 1 vertically. Then 1, 2, 3, 4, 5, 2 more horizontally, 1 more vertically. In the third pattern, we had 10. That's why we had 1, 2, 3, 4, 5, 6, 7 horizontally and 3 vertically, not considering the one in the base. You understand, I guess. That's why I have plotted this the left-hand side of this table in this way. Okay, this is very important. Now the next requirement, B, how many tiles will be in the 10th tile pattern? Using the same logic, the logic that we mentioned before, the one of using the common difference 3, we can easily guess 13 plus 3, 16, plus 3, 19, plus 3, 22, plus 3, 25, plus 3, 28 up to the 9th position. Then plus 3, 28, plus 3, 31 tiles will be needed in the 10th pattern without drawing the left-hand side part of the table. Now see how many tiles are needed for the nth tile pattern. For the nth tile pattern, we will try to guess, of course, or to find out a formula. And the formula in this case, it would be 3n plus 1, 3n plus 1. And 3n plus 1, pay attention. Since in the first case we had 4, we are thinking of 1 less 4. So of 3 times n plus 1 corresponds into finding out easily 4. 3n plus 1 is a formula which works for the second position, for the third position, for the fourth. It's obvious even for the 10th position. That's why this will be the formula representing the nth pattern in this table. Now the requirement D. In which position in the sequence is the tile pattern that has 334 tiles? So 334 tiles will be substituted into L, or like the example that we mentioned in the previous exercise, 334 equals to 3n plus 1. We solve this like a simple equation following the main steps, passing 1 from the right to the left-hand side, changing the sign, obtaining 3n in the right-hand side. 333 equals to 3n, implying that n equals to 111 tiles. 111 will be the position which will have 334 tiles. Now, the next requirement, explain where the nth term comes from using the picture. We will try to study again the picture carefully. For the first position, there are 4 tiles using the formula that we decided together. For the second position, there are 7 tiles, 2 times 3 plus 1. For the third position, 10 tiles, and so on. For the n position, there are n times 3 plus 1 tiles. So the nth term comes 3 times itself plus 1. So the nth position again, the nth term comes 3 times itself plus 1. Exercise 5, follow me on exercise 5. Look at this tiling pattern. Look at this tiling pattern. The first shape consists into 3 tiles, the second shape into 1, 2, 3, 4, 5, so into 2 more, the third into 7, and answering A, draw the next 2 shapes, we use the same difference that we were able to see in this example, 2 more. That's why this will the next 2 shapes will have 1, 2, 3, 4, 5, 6, 7, 8, 9. The next will have 11. For B, how many tiles will be needed for the 10th shape? Following the same difference 2 each time, we will be able to find that for the 10th shape, there will be needed 21 tiles. There will be needed 21 tiles. C, how many tiles will be needed for the nth shape? For the nth shape, there will be needed 2n plus 1 tiles. 2n plus 1 is the formula that looks like to the one that represents odd numbers also. For D, explain where the nth term comes from using the picture. The nth terms, of course, will come twice multiplying itself, adding 1. E, which shape contains 121 tiles? 121 will be equalized to 2n plus 1, though finding that n equals to 60. So the 60th shape will contain 121 tiles. Please follow now on consolidation exercises. Exercise 3 on page 230. It is given a tiling pattern, the one with the red tiles. You see the first shape, the second, the third shape. They do have one. The first has 1 space in the center, the second 2 spaces, the third 3 missing tiles, and so on. The first requirement is how many red tiles are needed for the 5th shape. For the 5th shape, there are needed 16 red tiles for the 5th shape you see. For B, how many red tiles are needed for the 15th shape? For the 15th shape, there will be needed 36 red tiles. I guess you understand the way how this pattern works, because you see carefully. In the first shape, there are used 1, 2, 3, 4, 5, 6, 7, 8 red tiles. For the second, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 2 more, but at the same time, it is added 1 empty space in the center. For C, how many red tiles are required for the nth shape? For the nth shape, the answer would be there are needed 2n plus 6 red tiles. For D, if the nth shape has 100 red tiles, what is the value of m? In order to find the value of m, we simply have to equalize 100 to 2m plus 6, which helps us obtaining m equals to 47 by simply solving it as an equation. E, justify your nth term by using the diagrams to explain where it comes from. The answer in this case would be the nth term would come by following the rule times 2 for the red tiles either side of the center and plus 6 for the 3 red tiles at each end. I hope it was clear for you the explanation of the way how these exercises are solved. That's why I'd like from you to solve the exercises as homework. Exercise 6, page 220. Exercise 7, page 220. And exercise 8 is optional on page 220. See you next time.